Hello everyone. Today we'll be discussing model-based software engineering, also known as MBAC, on AWS and its implication in software architecture and design thinking. The details of my team are as follows. I am Sushil Maurya, roll number 180, Bharat Mahesh, roll number 141, and Gaurav Kulkarni, roll number 164. MBAC is about reshaping how we manage complex systems. At its core, MBAC replaces traditional document-centric methods with digital models to define system requirements, behaviors, and structures throughout the product lifecycle. The primary goal of MBAC is to improve collaboration, accelerate development, and enhance decision making, presenting a unified visual representation of the system we are crafting. Now, let us delve deeper into how this concept is crucial for software architecture and design thinking on slide number 3. In the realm of MBAC, we employ graphical and textual models to represent various facets of the system. This includes its structure, behavior, requirements, and interactions. These models serve as a common language for interdisciplinary teams, promoting collaboration among diverse engineering disciplines. The use of shared modeling language is particularly relevant in software architecture and design thinking. It ensures that all the aspects of the system are thoroughly considered, helping us to avoid misunderstanding and incomplete design solutions. Moving on to slide 4. Within MBSC, we have dedicated software tools known as model repositories. These tools enable us to create, store, and manage our system models, facilitate version control, collaboration, and traceability, all of which are incredibly valuable when we talk about designing software systems. Additionally, MBAC involves simulation analysis, where we use models to run simulation and analysis, predicting system performance. We identify issues, optimize designs. In the context of software architecture, this can be invaluable tool for fine-tuning system behavior and performance. Now let us proceed to slide 5. Requirement management is a systematic and critical part of MBAC. It involves managing requirements within our models, ensuring that the requirements are met throughout the life cycle. The concept of traceability here is particularly vital in the context of software architecture and design thinking. It allows us to track design decisions and requirements back to the model, ensuring that the system remains aligned with the initial design and goals of the product. Additionally, MBSE model provide a visual representation, enhancing communication and understanding among team members and stakeholders. Effective communication is a fundamental aspect of successful software architecture and design thinking, as it ensures that everyone is on the same page and working towards the same objective. On to the sixth slide. Now let us talk about the numerous benefits of MBSE with a particular focus of software architecture and design thinking. First and foremost, MBSE significantly enhances collaboration, bringing together multidisciplinary teams and ensuring a common understanding of the system. In the world of software architecture, this is crucial as it demands the convergence of diverse expertise to create a coherent functioning system. MBSE also enhances efficiency by streamlining development with automated document generation, reducing the overall time and effort required for system documentation. This efficiency is significantly advantageous when we are thinking about designing software systems that need to meet tight deadlines and budget constraints. Traceability is another aspect of MBSE. It ensures that the requirements and design decisions can be traced back to the models, providing a clear audit trail. This traceability is essential in software architecture, where it helps maintain the integrity of the design and ensures that the changes are well documented. Lastly, MBSE leads to significant cost and time saving. By identifying issues early, avoiding rework, and improving communication, it significantly reduces the overall time and cost required for the system development. This is particularly relevant in software architecture, where minimizing the cost and time while delivering high quality software is always the top priority. As we conclude, I now pass the baton to my teammate Gaurav who will take us through how MBSE is applied in the software architecture on subsequent slides. Thank you for your attention. Gaurav, over to you.
Now I will be explaining MBSE in software architecture. In the domain of software architecture, MBSE acts as a guiding light, applying system engineering principles and modeling techniques to enhance the development of software-intensive systems. Firstly, the requirements, elicitization and management. MBSE allows architects to create detailed models of user requirements, ensuring a standardized and visual representation of user needs. Then the software architecture leverages these models to design systems that align precisely with specified requirements. The second point being the system modeling. MBSE facilitates the creation of comprehensive system models spanning software components, hardware, data, and their relationships. In the context of software architecture, these models offer a high-level overview focusing primarily on software components, modeling, and their interactions. Moving on to the next slide, we will be seeing the behavioral model and simulations. MBSE enables the modeling of system behavior, including intricate dance of software components. Architects use behavioral model to simulate runtime interactions, identifying potential bottleneck and areas for optimization. Design refinement and optimization. MBSE supports iterative design and processes, allowing engineers to refine and optimize the software architecture models based on simulation, results, and changing requirements. Software architects used MBSE tools for iterative design, considering factors like modularity, scalability, and maintainability. Moving on to the 10th slide, documentations and communication is an important feature. MBSE provides a standardized way of documenting both system and software architecture. Software architecture leverages MBSE to create a comprehensive documentation, ensuring clarity for all stakeholders, including developers, testers, and project managers. Requirement traceability. MBSE tools offer traceability features, allowing engineers to trace requirements throughout the development process. Software architects establish traceability between software components and requirements, providing a clear understanding of design decisions. Nextly, there is MBSE and design thinking integration. Now let's explore the dynamic syncing between MBSE and design thinking, two approaches that when integrated leads to an innovative and holistic development. Understanding user needs. Design thinking emphasizes empathizing with users to understand their needs deeply. MBSE complements this by enabling the systematic modeling of user requirements, translating it to technical specifications. Ideation and prototyping. Design thinking encourages brainstorming and prototyping. MBSE aligns this with the support of creation of virtual prototypes, enabling engineers to simulate and analyze various design alternatives. Prototyping and testing. This is the most important thing in the architecture and thinking. Design thinking involves user testing of physical prototypes. MBSE enhances this by allowing rigorous testing and simulated environments, ensuring robustness before physical prototypes are produced. Moving on to the next slide, we will be seeing the implementation and monitoring. Design thinking finalized solutions based on user feedbacks and real-world data. MBSE models remain valuable during implementation, serving as a reference to ensure alignment with specific requirements. Next being the iterative nature. Design thinking is inherently iterative, refining solutions based on feedback. MBSE supports iterative development by refining models, ensuring alignment with evolving needs and goals. In conclusion, the integration of MBSE and design thinking creates a powerful synchronization energy. MBSE provides technical depth, enabling rigorous analysis and simulations, while design thinking injects a user-centric, creative, and iterative approach. Together, they pave the way for holistic solutions, technically robust and user-friendly, fostering innovations and successful product development. The next slides will be explained by my friend Bharat. Thank you.
Thank you. So, coming to MBSE architecture and AWS in specific. So here we can see a demo AWS MBSE architecture made on AWS, and we can see various components which we'll talk about later, such as the artifact store, the digital continuity layer, or the extended workforce collaboration. So this is just to show how MBSC is implemented in a real world scenario. Now, we should focus on the foundational elements of how AWS empowers MBSC through its scalable, agile, and interoperable cloud services. Talking about scalability and elasticity, AWS offers managed services for object storage, databases, and compute, allowing dynamic scaling with minimal IT workload management. It includes various database options, both relational and non-relational, as well as serverless databases like Aurora and DynamoDB. For agility in IT and engineering, AWS brings automation and an experimentation culture, workflow management and event-based architectures, enhance transparency by reducing the need for extensive emails and meetings. Shared service platforms like SSP and service catalogs enable on-demand resource allocation, fostering innovation and high-fidelity simulations. Talking about interoperability and flexibility, AWS supports a microservice approach for flexibility, allowing seamless connectivity through application integration services. It also enables hybrid architectures, combining local AWS technologies and high-speed connections, offering interoperability between different systems and services. Now, let's dive into the advanced capabilities of AWS provides for MBSC, extending its reach globally, incorporating edge computing, integrating AI/ML technologies, and ensuring robust security measures. For when we are talking about MBSC in a global scale, AWS's extensive global presence ensures data sovereignty, low latency access, and global accessibility through read replications and serverless deployments. AWS Global Accelerator guarantees continuous availability through static IPs. Extending MBSC to Edge allows AWS to seamlessly integrate MBSC with edge devices, vehicles, and machines. It provides native offline capable solutions with lightweight processing, storage, and AI/ML support. Automation from design to production is achieved using AWS IoT, enhancing agility and responsiveness to designs, to changes and effects. When we're talking about AI/ML, which is present in every layer of MBSC, AWS integrates NLP technology for efficient collaboration. Amazon Neptune ML offers dynamic graph database insights, while SageMaker provides a wide array of AI/ML algorithms. Serverless technologies are employed for cost-effective transactional operations and CRUD activities, enhancing efficiency. Then we talk about granular access, identity management, and security, which AWS ensures secure international multi-supplier collaboration through granular access control. Robust identity and access management, or IAM practices, guarantee data security both in transit and at rest. AWS has been providing continuous support and expertise in the field of MBSC since 2006. Going beyond traditional MBSC and into innovations that AWS has brought in specifically, we'll first talk about the digital continuity layer. This layer standardizes digital threads using APIs and JSON payloads, ensuring seamless integration between diverse softwares and environments. Data ingestion from various sources, both internal and external, is facilitated through AWS services like Kinesis, enabling continuous flow of data into the MBSC system. And talking about orchestration for MBSC, we have services like Amazon Event Bridge, AWS Step Functions, and Managed Apache Airflow, which enhance visibility and transparency in micro-level engineering processes. This diagram illustrates how digital continuity and orchestration work together to streamline MBSC workflows and ensure data flow and communication between various components. Talking about the extended workflow collaboration, this allows different disciplines and suppliers to cooperate at a micro level, allowing for iterative designs and localized optimizations. Coming to the artifact store and catalog, AWS Glue enables the cataloging of various objects, facilitating easy querying of data through Amazon Athena. The concept of commonality in design, where insights from past designs are utilized for current projects, is introduced, showcasing the value of artifact store in enhancing engineering practices. Now, this diagram explains how workflow management is built on MBSC with the help of all the innovations AWS has brought in like the artifact store and workflows as explained before. In conclusion, I'd like to say that the integration of MBSE in AWS enhances software engineering by offering a systematic design and development approach. When combined with design thinking, it encourages innovation, user-focused design, and continuous improvement. The synergy results in the development of robust, user-friendly, and innovative software solutions, paving the way for a promising future of software architecture. Thank you. Our main reference for this presentation was an AWS white paper on MBSE, which is linked here.